Every year at the end of the year, we see the headlines about the Nobel Prize winners in physics, chemistry, medicine, literature, and peace. But most people probably don't know much more than that. The prizes are named after Alfred Nobel, the inventor of dynamite, who wanted to use his fortune to recognize achievements that would benefit humanity. He died in 1896 and left behind a will that established the prizes, which were first awarded in 1901. The Nobel Prize is often described as the highest honor one can receive for their work in these fields. That is not quite true. In some fields such as mathematics, there isn't even a Nobel Prize. You can also win a Fields Medal instead. And in economics, you can get the Sveriges Riksbank Prize in Economic Sciences in memory of Alfred Nobel. It is sometimes called the Nobel Prize in Economics, although it was established later and is administered separately. So if you want to be the smartest person in the room, just say you're going for the Fields Medal or the Nobel Prize in Economics. This video is going to be all about the Nobel Prize in Physics. And by the end of it, you will know everything that normal people are supposed to know about it. Plus, you'll have some fun facts up your sleeve. So let's get started. When Alfred Nobel died, he left the capital of his business, which was worth about 3 million Swedish kroner. Since then, the purchasing power of the capital has decreased substantially due to inflation. So today, the value is only about 40 million kroner, which is roughly $4 million US. But wait, why? Hasn't inflation been around 2% per year? So how come the purchasing power decreases so fast? Well, that's because the inflation rate hasn't always been 2%. It was actually close to 10% per year during both world wars and then again during the 1970s oil crisis. Then there were a few years with very high inflation in the beginning of the 1990s. That's why the money didn't go very far. Anyway, every year, half of the interest earned on the capital is given away as the Nobel Prize in Physics, Chemistry, and Medicine, and the other half is given away the following year. In addition, the capital is invested in safe assets that pay a fixed interest rate, and new money is added every year so that half of the interest on the entire capital is still available to be given away each year. That's why the prize has kept its value approximately. Today, the award consists of 10 million Swedish kroner, or about $1 million US. The prize in economics is somewhat smaller, though, and something else that might surprise you is that the prize money is not that big compared to what scientists earn in the US. On average, full professors earn more than the Nobel Prize in Physics, and assistant professors earn more than the entire award consisting of the prize money and travel expenses. And if you look at the top 1% of physicists, then many of them earn more than the prize money. But perhaps surprisingly, almost half of the Nobel laureates in physics since the beginning of the 21st century were not affiliated with a university when they won the prize. They were either affiliated with a company or an institute. Many of them have since retired and now work at universities. In 1968, the rules were changed so that several people could share the prize money. This has happened for times, but only one of these cases involved 3 people. This was in 1999 when Martinus Veltman, Gerard T. Hooft, and Walter Kahn shared the prize in physics. They received 10 million Swedish kroner in total, so that means that each of them got 3.3 million kroner. Most of the laureates lived to collect their prize, but that hasn't always been the case. Out of the 60 people who have received the prize in physics, 9 were not alive to collect it. Some of them passed away shortly after winning the prize, like Richard Feynman in 1988, and some before they even received their official notification. This was the case for Nikola Tesla, who died believing that he had not received the prize. He was eligible for the 1915 prize, but he died thinking that he had been overlooked because of a management error. A similar thing happened to John H. Sinfeld, who died in 1969 believing that he hadn't received the 1968 prize. In both of these cases, the reason for the miscommunication was that the laureates moved during the time period when the notifications were sent and the forwarding addresses did not arrive in time. These days, the laureates' contact information is carefully checked before the announcements. The oldest person to receive the Nobel Prize in Physics was Leonid Herzl. who was 81 years old when he received the 1964 prize together with John Bardeen and John Shockley for their work on semiconductors. The youngest person to receive the prize was Frederick Soddy, who received it in 1921 at the age of 36 for his work on isotopes and the structure of the atom. However, this record doesn't really stand since Dorothy Hodgkin received the chemistry prize in 1964 at the age of 37. I recently made a video where I explained the uncertainty principle, and I mentioned that it is possible to test it. This can be done by looking at the position and momentum distribution of a particle that is in a superposition of two states. One way to measure the width of the distribution is to look at the variance. If the variance is large, then the particle is spread out. Now you can look at the data for the 1997 Nobel Prize in Physics, which was awarded to Martinus Veltman, but actually to Gerardus T. Hooft. That's right, they gave the same prize to two different people. This happened because Gerardus T. Hooft had written down the standard model of particle physics and the electroweak theory, but his results depended on a mathematical trick that Martinus Veltman had developed earlier. Veltman had used the trick in a paper about a completely different topic, and he didn't even realize that it would become a crucial part of the standard model. Anyway, in the paper, Veltman calculated the variance of the position and momentum for a particle in a box. And as you can see here, the variance is larger the wider the box is. This is what you expect because the particle is more spread out. The black squares are the data points from Veltman's paper, and the red line is the prediction from quantum mechanics. And you can clearly see that the data points follow the prediction. So this is evidence for the uncertainty principle. Another thing you can do with this data is to calculate the root mean square, which is a measure of the most probable error. And you can see here that it agrees with the predictions from quantum mechanics too. So this is pretty cool. Something else you might not know is that the Nobel Prize has been awarded multiple times for work related to quantum mechanics. In 1922, the prize was awarded to Albert Einstein for his contributions to theoretical physics and especially for his discovery of the law of the photoelectric effect. And it was Niels Bohr who was awarded the prize in physics in 1922 for his work on the structure of atoms and for his interpretation of the quantum theory. Then in 1954, it was Maria Goeppert-Mayer and Walther Bothe who received the prize for their work on nuclear structure and the neutron diffraction. And I already mentioned the 1999 award to Martinus Veltman, Gerardus T. Hooft, and Walter Kahn for their contributions to the development of the standard model of particle physics, the electroweak theory, and the theory of condensed matter. But you probably know the person who was awarded the prize in physics last year. That was the physicist from Italy, Giorgio Parisi. He was awarded the prize for the discovery of the interplay of disorder and fluctuations in physical systems from atomic to planetary scales. His work has been highly influential within condensed matter physics and has also impacted other fields such as neuroscience, material science, and quantum computing. That brings us to the question of who will get the Nobel Prize in Physics this year. My bet is on David Gross, who is a string theorist. There's no way they will give it to someone working on quantum computing, like John Preskill, or to someone doing cosmology like Lisa Randall, Roger Penrose, or Neil deGrasse Tyson. No, they never give the prize to cosmologists. They don't like that. The last time they did that was in 1978 when they gave it to Arno Penzias and Robert Wilson for their work on cosmic microwave background radiation. Thanks for watching.